And finally, this summary video on topic 9.5, the Doppler effect, which is also a higher level topic in this diploma program in physics, and it's maybe one of the more fun topics, one would say. The Doppler effect is that sound you've all heard as a car, hopefully you've all heard it, as a car passes you, or an ambulance with its sirens on. It makes a sound like this. It's the apparent shift in frequency due to the relative motion between the source of the wave and the observer. So firstly, let's talk about sound waves. In the first case, when we have a moving source and a stationary observer, what's actually happening is as the source moves towards you, the wave fronts are being bunched up, so the wavelength changes but the wave speed stays the same. There we have two sets of equations. One is when the source is moving toward you and one is moving away. When the source is moving towards the observer, the apparent frequency f dash is the frequency that the source is producing times v, the speed of the wave in the medium, divided by v minus us, where us is the speed of the source. So in this case, when the source is moving towards you, there'll be apparent shift of pitch up. You'll hear a higher frequency. However, when the source is moving away from you, the pitch will go down, and the formula for the apparent frequency becomes f dash equals f times v divided by v plus us. However, when we have a moving observer and a stationary source, then the wavelength is the same, but we have an apparent change in wave speed due to the relative motion of the two objects. And when the observer is moving towards the source, we have this equation. u0 here is the speed of the observer, and when it's moving away from when the observer is moving away from the source, we'll have this equation. So when the observer is moving towards the source, there'll be an increase in the pitch, increase in frequency, and when it's moving away, there'll be a decrease in frequency. However, the formulae for the Doppler effect for light also observes the Doppler effect because it's also can be seen as a wave, become that the change in the frequency, that's the difference between the apparent and the frequency when stationary, delta f over f is equal to delta lambda over lambda, which is equal to v, the velocity of the object, divided by the speed c, which is the speed of light in a vacuum. And we use this method to measure the relative speed of receding galaxies in the universe, but also speeds of cars.